All right, everybody, what we're going to do in this video is write down the electron configurations for the first 21 elements. You're going to need your periodic table, so please go and get that, and you're going to need a piece of paper. We are going to review quickly the rules for writing electron configurations because this is where they're going to make sense. All right, and then we'll show you what they're like for these first 21 elements. So we have the off-ball principle that says electrons enter orbitals of the lowest energy level first. So we're using this diagram. So these are the lowest ones closest to the nucleus, and these are the highest energy that are going to be entered last. Then the Pauli exclusion principle says that an orbital can hold 2 electrons max, each with different spins. So we're going to show them with little arrows like so. And then we're going to use Hund's rule, which is the bedroom rule, that if you have orbitals that have the same energy level, so like the p, the d, and the f orbitals, see how they're all on the same level? 1 electron goes in each one first in the same direction, and then we start doubling up. Okay, so you're not going to do this. That is not what happens. All right, so what you need is that blank piece of paper where you're going to write down um, exactly this, the atomic number, the symbol, the number of electrons, and then we'll write out the electron configurations. And I kind of cropped this picture right here so that you can see where our lowest energy levels are going to be and our highest energy levels are going to be here. And remember, this is your off-bow diagram. All right, so let's start. So according to the periodic table, atomic number 1 is hydrogen, and that means it has 1 electron. So what we do is we put it in the position that is the lowest, and that means we're going to put it here in this first spot. All right, and for my electron configuration, I'm going to write in the 1s orbital, I have 1 electron. Okay, so if we take a look at 1s1, what that is really saying is this is called the principal energy level. Okay, so this is the first layer. This is the type of orbital. And this little exponent up here is saying the number of electrons in that orbital. So in the 1s orbital, there is 1. Okay, I'm going to draw a picture. It's going to get very complicated very quickly, but in the initial part, I'm going to just leave it like so. So here is my nucleus in the center, and what the electron configuration would look like for hydrogen is you would have an s orbital, which is spherical, and then you would put 1 electron somewhere inside of it. Okay? Now, the next element is element number 2, helium. It has 2 electrons. So what we're going to do is we're going to fill our first electron here in the 1s, and then that still has room, so I'm going to put another electron in the opposite direction right next to it. And what I'm going to write for my electron configuration is that in the 1s, I have 2 electrons. So that means over here in my picture, in the 1s layer, I'm going to have 2 electrons somewhere inside of it. Okay, number 3, lithium, which has 3 electrons. Okay, so I come over to my position over here. I put my first electron in the 1s, then my second electron in the 2s. Now that orbital is full. So think ogre, onion, layer. I'm going to go to my next orbital, which is the 2s, and I'm going to draw an up arrow right there. And I'm going to write in the 1s orbital, I have 2 electrons, and in the 2s orbital, I have 1 electron. So what does that mean for my drawing? In the 1s orbital, I have 2 electrons. In my next layer of s, I'm going to have one electron somewhere inside of it. Okay, number 4 is beryllium with 4 electrons. So I'm going to take and put my first electron in the 1s, second electron in the 2s. That's full. Now I put the third electron in the 2s, and then I'm going to put the fourth electron in the 2s in the opposite direction. So my electron configuration is 1s, 2, and in the 2s I have 2. So somewhere up here I have my 1s with 2. In my 2s I have 2. Element number 5, boron, has 5 electrons. So what I do is I go over to my off ball. I put the first electron in 1s, second electron in 1s, third electron in 2s, fourth electron in 2s. Now these 2 layers are full. So what do? I go to the next available and I put it in the 2p. And I write exactly what I drew over here, exactly what I filled in. In the 1s orbital, there are 2. In the 2s orbital, there are 2. And in the 2p orbital, there is 1. Number 6, which is, up here at the top, the drawing. So here's my 1s, here's my 2s. So then I do the 2p, and somewhere in the 2p, there is an electron. So number 6 is going to be carbon. Okay, so it has 6 electrons. I'm going to fill in 1 electron here, 2 electrons there, 3, 4, 5, and then my 6th one, according to Hund's rule, should spread out. Remember, electrons are negatively charged. They're going to repel one another. They're going to spread out as much as they can. So, what do I get from my electron configuration? In the 1s, there is 2. In the 2s, there is 2. And in the 2p, there are 2. So that means I draw another p orbital, and then I put an electron somewhere inside of that. Nitrogen. Okay, nitrogen is number 7, has 7 electrons. So what happens here? I put first 2 electrons in 1s, that's full. Then 2 electrons in 2s, that's full. Then I put 5, 6, and then I follow Hund's rule, number 7 right there. And I write down for my electron configuration. In the 1s there's 2, in the 2s there's 2, in the 2p there are 3 now. And remember, this p orbital is the z orbital, so that means it's going to come out towards you and away from you into the board. So we put our electron somewhere inside of there. And you know what's really cool is you can always double check and make sure that you have all the electrons. Because if you count up your exponents, 3 plus 2 plus 2, that equals 7. 2, 2, and 2 is 6. 1, 2, and 2 is 5, 4, 3, 2, 1. All right, so let's continue on with element number 8, which is our oxygen. Okay, so oxygen has 8 electrons. We're going to come up here, and if you were just filling this from the beginning, you would put 2 electrons in the 1s, opposite directions. Now that's full. Then another 2 here, that's full. Then you would put 5, 6, 7. Where would number 8 go? Well, these are only half filled, so now I can obey Hund's rule and put one in the opposite position in that first orbital. So I would write in the 1s orbital, there are 2. In the 2s orbital, there are 2. And in the 2p orbital, there are 4. So that means I have my electron in the center. In the first layer of S, I have 2 electrons. In my second layer of S, I have another 2 electrons. Then I have 2p, 2p, and 2p. And that's where I'm going to put in 1, 2, 3, 4 electrons. And remember, these guys here, 4, 2, and 2, should equal 8. And they do. So what about fluorine? Fluorine would be number 9. Okay? So once I have 9, I would fill that in right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I would write down for my configuration, there is 2 electrons in the 1s, then in the 2s there are 2, in the 2p there are 5. So that means I would go over to the other 2p and put an electron right there. In number 10, neon, I'm going to put another electron in this last position to fill up the 2p orbitals. Remember, p's can hold 6, 2 in each one of these lines. So that means I have 1s2, 2s2, 2p6. And you'll notice we just are getting bigger and bigger each time. All right, number 11, sodium. Okay, now that I have filled up my 2p orbital, now what's next lowest on the off-ball diagram? Remember, lowest to highest. So what I do is I write an electron right in here, draw one in the 3s. And I write 1s2, 2s2, 2p6, 3s1. So what does that look like? That looks like, now I put an S around the whole thing, and then I plop an electron somewhere in there. Okay, let's move on. Magnesium has 12 electrons. So where does my 12th electron go? In the next lowest spot, which means to fill up the 3s orbital right here. And I put in 1s2, 2s2, 2p6, 3s2. Remember, every single element has a different electron configuration. It is its signature. And you can always double check to see what the element is by doing 2 plus 6, which is 8, plus 2, 10, 12. This is number 12, and 12 is magnesium. All right, aluminium. Aluminium is number 13. Okay, what do we do with aluminum? Okay, the 1s is full, the 2s is full up to 4, 2p is full up to 10, 3s is full up to 12, so what's the next lowest energy level? Now I go to 3p, and I write what I drew. In the 1s there's 2, in the 2s there's 2, in the 2p there's 6, in the 3s there's 2, and in the 3p there is 1. So this is where it starts to get a little crazy. This is where you now draw another p orbital that is bigger and plop an electron. Okay, this is optional. This gets confusing. Okay, but this stuff over here, you can draw lines and arrows. All right, silicon, number 14. Okay, where does this 14th electron go? Goes in the next lowest position, according to Hund's rule, gets spread out. So it goes here. And I write for my electron configuration 1s2, 2s2, 2p6, 3s2, 3p2. And this is where I draw another p orbital like so, and then I add my electron to it. All right, in the next video, we'll do elements 15 to 21.